Hello and welcome to the second session in our webinar series on high precision bearings. In this episode, we'll take a closer look at one of the most important bearing types in this field, the high precision angular contact ball bearing, also known as a spindle bearing. We're glad to have you with us. Spindle bearings are a core component in the world of high precision bearings, and they're used in a wide range of applications, particularly in machine tools. In this webinar, we'll cover several key questions. What exactly is a spindle bearing, and how does it differ from other angular contact bearings? What are common contact angles and materials? And why are smaller balls often used in high-speed designs? We'll also take a brief look at sealing concepts and their thermal limits. And as always, we'll finish with a quick preview of what's coming up in the next webinar. Let's get started. A spindle bearing is a particularly precise, single-row, angular contact ball bearing with extremely tight tolerances. It's designed specifically for applications that demand high guiding accuracy, high speeds, and maximum rigidity, such as main spindle support. It's important to note, every spindle bearing is an angular contact bearing, but not every angular contact bearing is a spindle bearing. Spindle bearings have solid inner and outer rings, standardized dimensions, and ball retainers designed for high precision use. Axial angular contact ball bearings, on the other hand, are optimized for axial loads and don't fall under the category of spindle bearings, even though their load direction is also angular. One of the most important features of angular contact ball bearings is the contact angle, also called the pressure angle. It defines the direction in which force is transmitted from the ball to the raceways along an imaginary line between the two contact points on the inner and outer ring. Unlike deep groove ball bearings, this force transmission is not perpendicular to the shaft, but angled, which is where the term angular contact comes from. The contact angle determines how much axial and radial load a bearing can support. Small contact angles, such as 15 degrees or 18 degrees, are ideal for high-speed applications with primarily radial loads. Larger angles, such as 30 degrees or even 60 degrees, are better suited for higher axial loads, for example in spindle applications or axially preloaded arrangements. The right angle is selected based on the load direction and the application's performance requirements. In the world of spindle bearings, several standard series have become established, such as the 70, 72, and 79 series used by Japanese manufacturers and the 718 and 719 series common in Europe. These differ primarily in width and load capacity. For high-speed applications, smaller balls play a key role. Their lower mass reduces centrifugal forces and improves the bearing's kinematics, allowing for higher speeds and less heat generation during operation. Choosing the right material is critical for bearing performance and service life. Rolling elements are usually made from high-grade bearing steel. In hybrid bearings, ceramic balls are used. They're lighter, non-magnetic, electrically insulating, and produce less friction. This results in lower heat generation and enables higher speeds. When it comes to cages, brass, and high-performance polymers like PEEK are common, depending on the load and the lubrication conditions. Sealing also plays an important role in high-precision bearings, especially in grease-lubricated spindle bearings. A common choice here are NBR seals. That stands for nitrile butadiene rubber. These are contact-free and can handle continuous use at temperatures of up to 100 degrees Celsius. For higher operating temperatures, FKM seals, made from fluorocarbon rubber, are the better choice. They offer much greater heat resistance. In oil-lubricated systems like oil-air lubrication, FKM O-rings are also used to ensure reliable sealing and compatibility with different fluids. That brings us to the end of our second webinar. Today you learned what makes spindle bearings unique, what series and contact angle options exist, and why ball size and materials matter for performance. In the next webinar, we'll take a closer look at bearing arrangements, including O, X, and tandem configurations, and explain why correct alignment is key to achieving the desired preload, stiffness, and load handling capacity. We look forward to having you with us again. Thank you for your attention.